Hello and good afternoon or good morning, everyone. My name is Hillary Stevens. This is the Living Shorelines Community of Practice webinar. Today is August 19th. Today we'll be hearing about water quality benefits of oysters in the Chesapeake Bay. Everyone is on mute because of the large number of attendees that we have. If you have any questions that you would like to submit, you will note on the right side of your screen, you should have a control panel where you can enter questions in writing, and we will take those at the end of the session. This webinar will be recorded, and I typically post those to our YouTube channel. It should be up within a couple of days, so feel free to check back there. You can just go to YouTube and Google Restore America's Estuaries. It should be up, as I said, in a couple of days, and you can see the recording of this webinar and of the entire series going back over several years now. Restore America's Estuaries is a Washington, D.C. based nonprofit organization. We are dedicated to the protection and restoration of bays and estuaries as essential resources for our nation. As you can see from this map, we have member organizations located around the country on the East Coast, the West Coast, and the Gulf Coast of the continental U.S. These organizations are working in their local communities to restore and protect their local water bodies, and we serve as a convener and an advocate for them in DC. We have a number of different programs and grant programs that you can find out more about on our website. We also are very excited to be looking forward to the National Estuarine Coastal Virtual Summit this year. Will be from September 29th to October 1st. We've got a great lineup of speakers, and there'll be a lot of opportunities to interact as well with poster sessions that folks are submitting and different exhibitors as well. Early bird rates are in effect until August 31st, so I encourage you all to go to our website to find out more about how to register and put that on your calendars. I'm also very excited to announce the release of the Coastal Restoration Toolkit. You'll see the URL on your screen here. It's www.restoreyourcoast.org. A lot of really fantastic tools there that were developed probably with the participation of some of you folks in attendance today. We worked with a lot of our member groups, talked to contractors, landowners, practitioners about what they needed to better implement their projects. So there's a lot of great information there. I encourage you to go check it out. Today, our topic, as I said, is water quality benefits of oysters in the Chesapeake Bay. And our speakers you'll see here are Amanda Poscadas and Jeff Cornwell. A little bit more about them. Amanda Buscidis is the Coastal Resilience Program Manager at the National Wildlife Federation's Mid-Atlantic Regional Center. Amanda works with communities to develop and implement innovative wildlife-friendly solutions to climate change to protect people and wildlife. Amanda studied at the University of Maryland Eastern Shore and Salisbury University. Jeff Cornwell, after graduating graduate studies on Arctic lakes at the University of Alaska and a marine sulfide geochemistry postdoc at Texas A&M, Jeffrey Cornwell joined the faculty at the University of Maryland Center for Environmental Science, Horn Point Laboratory in 1986. His research program in UMSES has included nutrient and element cycling in wetlands, estuaries, and reservoirs within the Chesapeake Bay region, as well as aquatic research in numerous other areas around the country. So I am thrilled to introduce them. You'll see quickly at the bottom of this is slide information about Ray's website and program about Living Shorelines, as well as our Living Shorelines Academy website, which is a great resource with information for landowners and contractors working in that space. So with that, I'm going to hand over to Amanda.
All right, let's see. Can you guys see my screen?
We sure can. You're all set.
All right, wonderful. Hi, everyone. I'm Amanda Poscadas at the National Wildlife Federation, And I'm going to start this presentation by giving a bit of an overview of our work in coastal resilience nationally. Then I'll give you a couple of examples of our work in the Chesapeake Bay. And I'll turn it over to Jeff Cornwell to discuss some research that we have been doing together on water quality benefits of oysters in the Chesapeake. And at the very end, I'm going to tell you guys about something that we've been developing with Jeff and some scientists at UMCs, an innovative way to green gray infrastructure. So stay tuned for that. The National Wildlife Federation has been working for 80 years to help wildlife thrive and unite Americans to do that. One of our strategic plan goals is to protect and restore coastal ecosystems, to sustain fisheries and wildlife, and to protect people and wildlife from rising sea levels and intensifying coastal storms. Strategies we employ to reach this goal include accelerating restoration of large-scale coastal ecosystems and expanding the use of nature-based coastal features to reduce risks to people and wildlife. We also work to reform flood insurance and disaster preparedness programs to reduce development in flood-prone areas, and we focus mitigation measures on nature-based approaches to natural hazard risk reduction. Additionally, we're working to protect nearshore marine ecosystems. And some of the things we do, we work to put policies in place that protect or promote natural infrastructure, and we work to advance and communicate the scientific case for natural infrastructure approaches for risk reduction. We're also working to ensure that there's an adequate supply of service providers able to implement these nature-based products. The large-scale ecosystem restoration outcomes that we're looking for are securing funding for the most impactful restoration projects and helping to minimize project delays through enhanced coordination. We also work on nearshore and marine iconic wildlife to identify and advocate for projects that enhance manatee and sea turtle habitat. And we work to make the benefits of policy to specific wildlife species more evident. Some of the activities we use to do this are developing widely utilized reports and training programs to provide guidance for conservation practitioners. We also work on federal policy reform, and we work to secure investments in large-scale ecosystem restoration throughout the country, including in the Gulf of Mexico, the Everglades, the Chesapeake Bay, the Delaware River watershed, and the Mississippi River Delta. Priority projects that we work on include nature-based approaches that showcase technical innovation and with the opportunity to replicate them at scale nationally. So an example of one of those reports that we've recently released is called Softening Our Shorelines. The link is on the slide. And this was a partnership between our coast team and the Coastal States Organization, where we conducted an inventory of state policies and regulations that inform the implementation of various forms of living shorelines. We also worked on national policy advocacy to reduce barriers to living shoreline implementation through this project, such as supporting the 2019 Living Shorelines Act. And we're working to provide a service provider training program or a module for marine contractors so they have the know-how to implement these projects, living shorelines particularly well. And we used resources from across the nation, finding the best ways to provide a training program from a bunch of different sources. So that report's now available. One of the most recent Chesapeake Bay projects that we've worked on is the Crest Beach Living Shoreline. This was an innovative partnership with the Maryland Department of Natural Resources and Queen Anne's County. And the project is located between Chester and Corsica rivers in the Chesapeake Bay. The reason it was innovative is it was the first shingle beach living shoreline tested in the US. And this type of shoreline uses pebbles or small cobbles rather than traditional sand. We incorporated climate resiliency into the design by incorporating small dunes to serve as a barrier to storms and rising tides, which will be able to migrate inland over time. and we're monitoring over a period of time to ensure that we can deliver the results of this type of project nationally. Another project that we are currently working on is in the town of Oxford, which is on the eastern shore of Maryland in the Chesapeake Bay. This is a partnership with the town and the Maryland Department of Natural Resources, where National Wildlife Federation worked as a technical assistant to develop design features that were innovative and promoted creating intertidal wildlife habitat necessary for species to thrive, like horseshoe crabs, terrapins, fish, and invertebrates. This piece of the design on the slide here shows an innovative concept of using living islands offshore where you don't have much space to work. So in the town of Oxford, the town is basically a lot of spaces have been eroded up to roadways or infrastructure. So this is an innovative approach to creating more habitat and providing risk reduction and resilience to this town. So we've designed multiple features throughout the town, and we're going to be working on implementing and monitoring over a period of time in the next few years. Another thing that National Wildlife Federation works on is supporting research and coastal resilience in the Chesapeake Bay. We're working with scientists at the University of Maryland Eastern Shore, like Jeff, to help promote studies of oyster castles and these natural infrastructure approaches for risk resilience on the coastlines. Now I'm going to turn it over to Jeff to tell you a little bit more about his research, and then we'll turn it back to me at the end and I'll tell you about a little bit of an innovative concept we've been working on. Let's see.
Screen. And thanks, Amanda. I seem to be at the end of my presentation. So I'm going to give an overview of the, let me see if I can get, I don't know if you can see, do you see just my presentation or do you see a lot of other pieces on the screen?
You can see it. Yeah, it's just the slides.
Okay, good. So I'm going to talk about the water quality benefits of oysters in the Chesapeake Bay. And I'm going to emphasize where we're going in terms of putting oysters on engineered structures. As with any program and the understanding that's been developed for an area of science and management like this, there's a lot of different people that have been involved. The program that working with Amanda include Matt Gray and William Narden and Michael Owens, all here at the University of Maryland Center for Environmental Science, Horn Point Laboratory. A lot of the work I'm going to show in terms of showing some data is Lisa Kellogg at the Virginia Institute of Marine Science. And beyond that, there's a plethora of interns and other folks who have contributed to this work over the last decade or so. So when you think about oysters and removing nitrogen, the thing you have to go a little bit into is thinking about why do we care about removing nitrogen? Well, in the Chesapeake Bay, nitrogen and phosphorus, though they're essential elements needed to grow algae and all of the plants, not just within the bay, but within the watershed, but the excess amount leads to a large amount of algal production. And the high amount of algal production has consequences that include the loss of water clarity, which affects submerged aquatic vegetation. We have extensive seasonal anoxia in the main stem of the bay, below about 25 feet. We have blooms of harmful algae. And what we do is when you create a anoxic bottom habitat, you really limit the amount of habitat available for different animals that use benthic resources. So what I want to do is talk about how oyster removal of nitrogen and phosphorus fits into a larger scale Chesapeake Bay management scheme. Use the work we've done at Harris Creek and the NOAA and Corps of Engineers and Maryland Department of the Environment work there to talk about the potential and show a bit of data in terms of how we're taking this kind of information and applying it to management, and then introduce our data on which is really the first of its kind on engineered structures, both reef balls and oyster castles. So some definitions. Denitrification. Denitrification is a natural process, the removal of fixed nitrogen, things like nitrate, organic nitrogen, all these forms, through microbial action are transformed into N2 gas, which is relatively inert. And that's a net removal of nitrogen from a water body. This process doesn't occur just in oyster reefs. Wetlands denitrify at high rates. And the larger scale industrial process of this is what we do in most of our wastewater plants in the Chesapeake Bay, is we have a what's called BNR, biological nutrient reduction, which is essentially denitrification. So now a wastewater plant might put out 20% of the ammonium and organic nitrogen that it used to 2 decades ago. A best management practice is an improved practice credited towards meeting water quality goals. One of the biggest ones here where I live on Maryland's Eastern Shore is cover crops, and they're put in each winter to tie up a lot of the nitrogen in soils so that it doesn't become a pollutant in the waterway. And then the other is total maximum daily load. And if you have a water body that's impaired, there's an assessment done that determines the total amount of nitrogen and phosphorus input that could be put in but still meet water quality goals. And it's lots of different segments of the bay have their own TMDLs, but it's a management tool to set the goals in terms of what we want to remove in terms of nitrogen and phosphorus. Now, the Maryland wild oyster harvest has had an unfortunate decrease over many years. And this is the harvest. It's not exactly population, but it's an analog to it. And so you're looking at, 10,000 bushels at the turn of the 1800s to the 1900s, and kind of a steady number around 2 million bushels up to the point when we had a number of diseases come in. And since then, the wild harvest has been terribly diminished. Right now, aquaculture is not quite as large as the wild harvest, but it's coming up on it. And that may be in the end where we have the biggest increase in oyster populations, but also in terms of the commercial harvest of oysters in the Chesapeake Bay. And so this is something I thought about long ago, mostly for wetlands, but it really fits here. And that is when you read a literature, sort of a promotional literature saying oysters do all these wonderful things for a system. Oysters are great for the environment. They filter so many gallons of water a day, and they remove nitrogen through biomass secretion and the production of N2. And so this idea has been around for a long time. The problem is there wasn't a lot of data to go with it. And so the relevant data is developing techniques and generating sufficient data sets to generalize so that we know there's elevated dinitrogen flux in cores taken near reefs. Work's been done for about 15 years. Whole community incubations, the approach that our laboratories and Lisa Kellogg's laboratory uses, and as well as Wally Fulweiler's up in New England. And what you're looking at there is whole community incubations where we essentially determine how much dinitrogen is taken out of not just the sediments, but the clumps of oysters and the abundant other organisms that are associated with oysters in restoration. And also there's a part of this, which is quantification of removal rates. When you restore a reef, you are building up an increment of nitrogen and phosphorus into the tissues as well as into the shell of the organism. Oops. And the policy part of this is important as well, in that what we have to turn this from the kind of a scientific study that we start out with to a management tool is we have to say, do we have sufficient data to come up with numbers to make this a best management practice? So already through the work of the panel that I chair, we've credited nitrogen removal in tissue with aquaculture. So an aquaculturist will basically be able to calculate how much nitrogen there is on oysters of a given size. And there can be trading potentially on that, but the key thing is the fact that we're now assessing the amount of nitrogen removed. And the question is, can we credit denitrification? And that's where that comes into these structures that we're going to talk about. Getting involved in this kind of endeavor, policy work, is not for the weak of heart or mind. This is a long process to work through all of these. So to develop a BMP, you have a diverse number of interests that are represented on the panel. We have lots of scientists, and we have really an all-star science group on the panel. And we're working at this very, very hard to come up with either default rates or other approaches that can be used to start crediting denitrification. Where it gets tricky is there's a decision point in how do we have enough information. And so that's a big part of what you do in these panels, is determine whether or not you have enough numbers out there to have the panel, but also to come up with recommendations. So if you look at a place, a restoration, doesn't have to be Harris Creek, but other places, you look at the whole mass balance of the ecosystem, and you're looking at nitrogen coming in from the watershed. In the case of Harris Creek, it actually washes in to Harris Creek from the Chesapeake main stem, which actually is, well, nitrogen inputs are dominated by the Susquehanna River drainage. And then we start, as well as atmospheric inputs. And then you're looking at what is the fate of the nitrogen. It's going to grow algae, but that algae can be assimilated and stored in oyster biomass. It can be buried. It can be passed back to the Chesapeake main stem. But what we're interested in is this term in the upper right here, denitrification of oysters in sediments. And that removal term becomes a very important mechanism for taking nitrogen out of the ecosystem. So the hard part is coming up with defensible, verifiable estimates of nitrogen reduction from this enhanced denitrification. Now, I'm using the term enhanced because denitrification is occurring in sediments before you do the restoration. And so you have to be looking at the amount that increases over the pre-existing amount. So if you take a place like Harris Creek, it's really 350 acres, about the size of the National Mall in Washington, D.C. And we're turning what is really often in other places a very flat kind of reef structure, we're making into a 3D structure. What we do is we embed trays, bring them back to the laboratory, seal them and incubate them. And what we're looking at and what are the benefits? The costs are about $28 million for the construction of these 350 acres. And the benefits are not just, of course, with water quality, but they accrue in terms of habitat and just getting more oysters out. So in the real world of making measurements, you end up with a scatter of data. And so I would say reasonably accurately right now that the science in terms of how this is exactly done in all the different places, we don't have the predictability. We have some correlations with biomass. This is just oyster biomass, but sometimes we get better correlations to the biomass of polychaete worms and other organisms within the reef structure. But these denitrification numbers are high, and it's this kind of relationship that we're going to exploit. The very early work we did in the upper chop tank came up with these 3 high points that have never been replicated anywhere else. But even these numbers that we're using here become pretty big numbers in terms of removing nitrogen from the ecosystem. And so there's a variety of different ways to look at this. We can bin our data into N2 fluxes for low, medium, and high biomass, which turns out that we're looking at numbers like 15 or 20 or 30 in terms of the low. The medium, about 150 grams per square of dry weight per square meter, and then on up. Well, what's interesting, it's linear here, but up in the upper right panel here, it's not a linear increase. We're having a very, very large increase in oyster biomass. So we're not looking at a simple relationship to biomass in all cases, but that probably ends up being the model we'll use in the long haul. One thing we observed is that in the lower right panel, what we're seeing is I'm just going to explain it rather than go through the details. But when you remove the oyster clumps in our trays and incubate them separately, we see that most of the denitrification moves with that. And so incubations of sediments alone do not appear to really capture an important part of the denitrification. So the oyster BMP in the Chesapeake Bay, what's approved is an aquaculture harvest removal of nitrogen in live tissue. Now for restoration sites, we're looking at two means of crediting. Default measurements for subtidal sediments and communities are likely to be part of what we're doing. Site-specific measurements, absolutely, because we really don't have, we have enough data for some seasons to come up with default measurements, but if you really want to credit things fully, you might need to go out and make some measurements, which is unfortunately reasonably expensive and difficult. Right now, denitrification is geared towards the kind of restoration you find in large-scale restoration projects, but we're also even though we're starting to develop numbers on these engineered structures, they are eligible for crediting in what we're going to be putting forward, but we need site-specific numbers. So if you have a reef ball that you put on the bottom and it has denitrification, you need to do enough measurements on those to determine what kind of crediting and total nitrogen removal that you could have. Right now, aquaculture, on-bottom aquaculture, water column aquaculture, floats, cages, really don't have enough data to move forward in terms of considering that. That's a lack of information that's there. So reef balls, there's a lot of them here. Where I am sitting right now is a couple hundred meters from the Choptank River. And in that Choptank River complex, there are about 400 reef balls and a little bit towards the upper part of the system. And then there's over 1,000 in the lower part of the system. So these have been put out for habitat primarily. We took advantage of an invitation from the Chesapeake Bay Foundation to go out and make some measurements with this. And each reef ball is about 60 centimeters diameter. The surface area inside it out about 2.6 square meters. You can see in the upper right here, the concrete that's used. What we did is we retrieved the reef balls. Divers went down and attached straps, brought them up onto a boat, and put them in a tank that we sealed up, just like we would with a sediment core for other kinds of experiments. And the lower right part, panel, you see this is one of, we had several reef balls that came up that were just 100% covered with oysters. Very, very impressive. And so again, all these little dots are reef ball deployments. You know, they were deployed, you ended up with over almost 7 million spat on shell. It's 6 point, yeah, and over about 8 acres. So this is a substantial amount of work to do this. A lot of volunteer hours put into their deployment. What we saw in terms of the numbers is on an aerial basis, these are amongst the highest rates of nitrogen removal you can find in any system. However, comparing it to a place like Harris Creek, there you have 350 acres, and here you're looking at a much smaller footprint of each of these individually. So even 1,000 of these is not a huge amount of area, but there are also sites where there's extremely intense removal of nitrogen. Now, the project we're working on with Amanda is At the Horn Point Laboratory, we have a lot of erosion here on the property, and so we're looking at an area here on the upper left panel right towards the entrance to the Choptank River. And we're seeing a tremendous erosion, lots of trees falling in, and Matt Gray and Amanda and the crew have deployed lots of these little blocks. They look like cement blocks in some ways, and some of these have been set with oysters, oyster spat, and others haven't. But you can see in the lower part, this is an area that's changing fast, and erosion is really taking away an awful lot of the shoreline. Here's a picture of two of these oyster castle blocks, and these are 2-year-old oysters, and this is an impressive number of oysters in a relatively small area. And what we did is we transfer these into the same kind of tank system we use for the reef balls. And where here is a circulating pump, you need to keep the water column homogeneous for this. Excuse me. And we've just done a little bit of work last year and a lot more coming up next week. But if we extrapolate these numbers, excuse me, if you look at the left-hand panel, so what happens in the course of the incubation is you're seeing oxygen going down, and it's going down fast. And then you're watching dissolved dinitrogen going up. So we can use this change to get a rate of increase of dinitrogen, and we can relate that to the blocks that we incubated. So if we extrapolate to the main warm season period, ignoring that there's probably denitrification when things are slightly cooler, we come up with about 6 grams of nitrogen per year per block, or 0.013 pounds of nitrogen, using what people consider a conservative amount of value for nitrogen removal. Each block was worth about $0.50 of nitrogen removal, in addition to the value of shoreline protection. The proposed BMP would credit the nitrogen removal. So a 1,000 block project would be valued about $500 per year for healthy oysters. And so this is not going to defray the total cost of installation by any means, unless we don't know enough about the sustainability over these extremely long periods of time. But the fact of the matter is, it is something that can help to some degree defray some of the costs of doing the shoreline protection. So next week, we're going to do a lot more. We've got now some 3-year-old oysters. We've got them in several different kinds of positions, including some on some breakwaters further out from the system. And it would be great to think about doing this work beyond our Lakes Cove project, just to see, in order to ever really consider this as a BMP with default rates, you really need a lot more data than we have. However, the numbers we're generating would certainly qualify it for a BMP when that's approved. Getting initial data published to help get the BMP crediting started is an immediate goal. We have a sufficient number of incubations for the reef balls, and we're working on that now. And by the end of August, we'll have enough data to try to get this information out to at least give people a flavor for how much nitrogen can be removed. One thing I wanted to point out is that with regard to oysters and denitrification, our knowledge base is growing extremely fast. And so we're not singular in terms of what we're doing here in the Chesapeake Bay. We have colleagues up in Rhode Island that are doing interesting things. Wally Fulweiler's lab and others in New England also are doing interesting things with both aquaculture and restoration. We've worked, of course, a fair bit in the Chesapeake, but Ashley Smith and Mike Peeler down in North Carolina, and Ashley's currently in Florida, but work's going on there. Jane Caffrey and others have been looking at some of these same processes in the Gulf region. And so there's interest in nitrogen removal in many different places. If you search on oysters and ecosystem services, you're going to find an awful lot of literature from the last 5 years. And I think some of the literature so far is outrunning the science, but we're certainly getting there in terms of our understanding and generation of rates that are relevant to doing that. And so the last thing I'd point out, this is really what got us going with Lisa Kellogg when she was in my laboratory. We worked on the technique, and this 2013 paper caught the eye of the Washington Post editorial cartoon, and we strongly agree that oysters that filter nitrogen are sunken treasure. And with that, I'll pass this back to Amanda.
Thank you, Jeff. Let's see. So I wanted to go over a little bit about the greening the gray technique. We've been working with Matt Gray and William Narden to actually identify how well these oyster castle structures reduce shoreline erosion. So they've been doing a lot of modeling work, a lot of biological surveys as well, in addition to the nitrogen removal research that's going on. And that data is going to be ongoing, that research is going to be ongoing, but really quantifying how well these structures, when placed offshore of a shoreline, can benefit the shoreline or marsh behind it is what we're also working on. And one of the concepts that kind of came out of this work, as they were doing modeling work with different structure assimilations, is thinking about offshore breakwaters that are made of rubble or stone, and thinking about, as these projects age, these projects have been put in throughout the Chesapeake Bay and in many other regions. And as these projects age and as sea level rises, they become less and less effective from an engineering standpoint to reduce shoreline erosion. So our idea, we call it the oyster veneer concept, is to plant oyster castles on and around offshore breakwaters in order to create a more resilient and more long-term, long-lasting project as sea level rises and climate is changing, and also planting the entire structure with oyster spat. And we're going to be working on modeling and designing this work over the next year, and we're really excited to share our research in the future. Special thanks goes to the Palmer Foundation for helping to support this work. And if anybody has any questions, let us know.
Okay, thank you so much to Amanda and to Jeff. Let me get my camera back on here. There we are. Okay, thank you so much. We do have a couple of questions, if I might. First one, I think this is for you, Jeff. Was the Oyster BMP panel convened by the EPA? Are they looking for nationwide credits or estuary specific?
This is specific to the Chesapeake Bay. And so, you know, I think, you know, the level of detail we're going through, what we're doing and the level of documentation we're doing, I think is transferable to other places. But it's specific to the Chesapeake Bay right now. And we're using Chesapeake Bay data for our default rates in terms of oyster restoration. But I think, you know, this is, you know, a labor of love as it was. We're on this almost 5 years, and we've gotten approved the first in-water best management practice. And what I mean by that is, you think of all the other practices, you're taking things out of the terrestrial ecosystem before they get to the bay. The opportunities to remove nitrogen after nitrogen comes into the water, and something that you can change the system and increase the removal, aren't very many things. Tidal wetlands come to mind, oyster restoration, or other aspects of adding oysters to the environment are the other. But the short answer is, this is Chesapeake Bay. I think the reality is we're doing a lot of the hard work that hopefully will be transferable to other places.
Great, thank you. This one could either be for either one of you, so I'll let you take a stab at it first, Amanda. What is the process for permitting installations? Is there limitation to install these infrastructures near urban settings? And what are the limitations to scaling up oyster restoration and nitrogen removal through this technique? So a couple different things there. Again, to recap, what are the permitting requirements? Recognizing those are local, but I guess if you can speak to what the Chesapeake is looking at, and about using these in more urban areas.
So for permitting, you go through the state. You need a state permit for installing these structures. And the local requirements, I don't know, I don't think there are any issues with installing these off of urban areas. I think the only issue you would run into is whether or not there's boat traffic and where they're installed related to channels. So it would have to be an area that's close to the shoreline where boats aren't going to be, running over them. We're often asked to mark these structures just to make sure that that's not an issue. And Jeff, do you have anything to add to that?
I do. In terms of urban areas, one of the concerns when you deploy oysters is that because urban areas often have higher levels of bacteria and contaminants, there's a concern in some places that you would deploy them that people, whether they should or should not harvest oysters, will do that. And that when you bring those back, the potential for issues with bacteria and contaminants comes to, it's not a small deal. And in fact, there have been places where people have decided not to deploy oysters simply because they're concerned about people collecting them and eating them in places where they shouldn't take them. In terms of scaling up, it really comes down to very simply a square meters. How much of this stuff do you get out there? And so if you've got a ribbon of oysters growing on this gray infrastructure along the shoreline, it's going to take a fair bit of shoreline to get lots and lots of acreage in there. But what I can tell you is the people I work with, the Chesapeake Bay program, they're looking for crediting all removal processes that remove nitrogen. And so we have things where wastewater takes out massive amounts when we improve those plants. We have other processes, stream restoration, that take out much smaller amounts. And so in terms of the best management practice part of this, we're looking to credit what is done, recognizing this is not the one thing that's going to change fundamentally the Chesapeake Bay. This is an incremental approach to remove nitrogen in many places, and it's additive with all the other best management practices that are out there.
Great, thank you. Next question. Who are the main funders for these initiatives? Amanda, I'll kick that to you.
So for the funders that we're working with are the Palmer Foundation and National Wildlife Federation. But I believe this is mostly university funded research. Is that correct, Jeff?
Yeah, what we've done, most of the funding that has generated a lot of the data for the best management practice for oyster restoration, it's money that's come from NOAA, the NOAA Chesapeake Bay program. But we've also gotten some funding from private sources early on. And so it's a variety of places. Maryland Sea Grant is another place that has supported a number of these activities. And so it's not one place that we go to that seems to have all the funding for this. And in fact, what we're doing here in the Cove, for instance, this is not a gigantic project, but it's the first of its kind regardless. And sometimes you just need to do a little bit of work to get a sense of how much more effort is really useful to move forward in these things.
Next question. Did you examine the quantity of other organisms growing on the castles? For example, biofilm, barnacles, ribbed mussels, or others? Jeff.
Not so far. And that's going to be something that Matt's going to look at in terms of the community aspect of it. What I can tell you, though, is when we worked in Harris Creek, Lisa Kellogg has done a complete assessment of the community associated with that. And like I was saying before, oyster biomass tells you a lot about what's going on in the system. For some reason, the correlations to mussels and the correlations to polychaete worms is even a better predictor of denitrification. And so we strongly believe there's lots of community interactions that seem to be a part of how denitrification occurs. And certainly a lot of these other organisms filter water. And so we bring up reef balls, for instance, and they're covered with bryozoans and other filtering organisms, even in ones that didn't get set with oysters. There might be no oysters at all, but there's still filtration going on. So it's always going to be a community.
Great. Next question. What effect does sediment loading and turbidity have on oyster denitrification rates? Are restored oysters too busy? And any plans for stable isotope tracer studies to confirm the fate? Jeff?
Yeah, it's backing up one step. A lot of loss of oyster reefs in the Chesapeake Bay come when basically they're not keeping up with the amount of sediment coming in and they get buried. And so if you look at sub-bottom profiles in numerous places in the Chesapeake Bay, we have lots and lots of buried oyster reefs that are not viable anymore. And so, you know, they are busy sorting basically the good food from the stuff that they're clearly not going to eat. And the generation of biodeposits always is going to be a big key part of how denitrification occurs. This is a microbial process. There's some indication that the microbes that denitrify do occur in the gut of the organism, but most of it's going to be associated with processing of those biodeposits within the system. Stable isotopes could be useful, but we're looking at a system that's primarily algal driven, so we're not looking at multiple sources of organic matter. And so it's possible you might be able to do some things like parse out where denitrification occurs, because we're measuring it on a per square meter basis, and we know a lot of it moves with oyster clumps. How exactly that happens, is it biofilms like the question had, or is it within these I mean, some of these shells that we have might have 10 to 50 polychaete worms in them, and you may have back chamber areas that are processing a lot of organic matter and denitrifying. And so there's for those if there are students listening, we're really at the tip of the iceberg of understanding all the processes that occur that result in these high rates of denitrification.
And moving on to some of the geology, have you found if the presence of oysters on the structure helps with shoreline stability? Is it mostly attributed to the structure itself?
We don't have the right person on the call for that. And we're in the early stages with this project to answer that question. So the idea is there's going to be a lot more friction by having the 3D structure associated with the oysters there, and that we might break up the waves a little bit more effectively and possibly trap more sediments behind these areas. But I think this is at the early stage, and a definitive answer really isn't possible.
Okay, thank you. Great presentation. I had a question on the denitrification calculations. How did you select the $40 a pound value?
That's a good point. And my colleagues that are more on the economic side think that's really low. But the $40, I've gotten involved in a lot of issues in the Chesapeake Bay. And the $40 comes from when they were looking at sediments coming from the lowest reservoir on the Susquehanna River, immediately above the tidal Chesapeake Bay. And when there was a sort of evaluation of, hey, you know, we're not trapping sediments are coming through. That was a number that was used at that point in time as evaluation, but you can pick any number. I've seen values a fraction of that, and I've seen values 4 times that. This is, yeah, I don't know what the right number is. I just used a number, and you know, if it turns out to be 10 times as much, all of a sudden it looks like, wow, we better grow oysters because the value of removal is phenomenal. Um, but I'll leave that to folks that spend their life worrying about how much a pound of nitrogen is worth.
Okay, thank you. One final question here, if you will, and thanks for your patience. We've obviously got a lot of curious folks. What has been the reception by the local communities to this project? And Amanda, I'll put that one to you.
So this project is along Horn Point Laboratories campus, and we've had local community members like school groups come out and really learn about these types of nature-based features with Shore River, it's one of our local partners. And we've really had some great support through that program, as well as I believe there's been some laboratory exposure as well from students and a lot of learning going on around this project.
Oh, that's great to hear. Jeff, did you want to add anything there?
Yeah, I think you know, this is a pilot project to see how this all fits together, and you know, taking this to more places and implementing it in an experimental way elsewhere probably is something that needs to be done before you would have a large scale investment in this. But I think this is a really good first step. Certainly from a biogeochemical viewpoint, it's fun for us, and I think useful to have this kind of information generated. But yeah, I still like that question about the $40. I think, you know, I'm thinking, gosh, if I can get $400 for this, maybe I'll go into business when I retire and just plant oysters.
Now let us know when you're looking for partners and investors, all right?
Okay, yes.
All right, I think that's our questions, and we're about at time here today. I want to thank you both for making time to be here. This is a fascinating topic, and I think one that's relevant to a lot of the folks working in this space. So thank you again, and to everyone listening, again, feel free to jump back to, you'll find more information about our summit on Ray's website. And if you're looking for a recording of this webinar, if there's something you missed, or if you want to pass it on to colleagues who weren't available, I will have this up in the next couple of days. It's just on YouTube. Look for the channel for Restore America's Estuaries. Thanks again, and enjoy the rest of your afternoon.